Today we will be looking at trigonometric functions. To begin, we will take a close look at the functions sine of x, cosine of x, tangent of x, and their function inverses, arc sine, arc cosine, and arc tangent. So first, let's start by making a graph of sine of x. So here's x, here's y. Let's say this is pi over 2, pi, 3 pi over 2, and 2 pi. Then on the left we have minus pi over 2 and minus pi. And then on the y-axis we have plus 1 and minus 1. So the function sine of x starts at the origin, and it curves up, hitting y is equal to 1 when x is equal to pi over 2, and then it comes back down like this. So it's supposed to be a nice smooth arc, and then it comes under like that. So that's what sine of x looks like. And then cosine of x, well, also on the other side we have sine of x coming down and going up like that. So sine of x is this same basic shape that repeats itself over and over again as you scroll left or right along the x-axis. Cosine of x is very similar, except it starts at 1, and then it comes down here, it comes under, it comes up like that. And then of course it repeats. So here it comes down like this, and it comes over like that. So that would be cosine of x. Now you'll notice that cosine of x, if you look at the points on sine of x and just shift them over by pi over 2, you would get cosine of x. So cosine of x is just a horizontal shift or a horizontal translation of sine of x. So all of these values are just the same values, same outputs as sine of x, except shifted pi over 2 units to the left. So therefore, since this is a shift to the left, we know that cosine of x can be written as sine of x plus pi over 2. Just like that. So next, let's look at a few basic values for sine and cosine. So let's make a table, x, sine of x, and cosine of x. So let's start off with x is equal to 0, pi over 6, pi over 4, pi over 3, and pi over 2. So pi over 6 would be 30 degrees, pi over 4 would be 45 degrees, pi over 3 would be 60 degrees, and then 90 degrees. So sine of 0 is 0, and sine of pi over 2 is 1. In between, we have sine of pi over 6, which is 1 over 2, sine of pi over 4, which is 1 over the square root of 2, and sine of pi over 3, which is the square root of 3 over 2. And then cosine goes in the opposite way. It starts at 1, and then we have the square root of 3 over 2, 1 over the square root of 2, 1 over 2, and 0. So these are some basic values, basic outputs of sine and cosine for some common angles that you should learn and memorize. Now the tangent of x is just defined as sine of x divided by cosine of x. So to get some values for tangent of x, so let's make a little bit more space here. Tangent of x. We just divide the sine x value by the cosine x value. So we have 0 divided by 1 is 1. 1/2 divided by root 3 over 2 is 1 divided by root 3. 1 over root 2 divided by 1 over root 2 is 1. Root 3 over 2 divided by 1/2 is equal to root 3. And then 1 divided by 0 is undefined. So the tangent function looks like the following. So if we draw a graph like this, x minus pi over 2, pi over 2, and we'll draw some dashed lines, so just to so we see where these two x values are. So the tangent function starts very close to this vertical line, and it curves in, and then it curves up, and then it goes up like that. Just approaching this vertical line as you get closer and closer to pi over 2. And then that pattern repeats. So it repeats. It comes up like this, and then it goes up like that again. So that's what tangent of x looks like. All right. So next, let's look at some basic inverse functions. And we'll start with sine of x. So suppose we have, let's look at our graph of sine of x again. So sine of x, so here's minus pi, plus pi, pi over 2, and minus pi over 2. So in order for a function to be invertible, it has to pass the horizontal line test. Now since sine of x, okay, this is not to scale, but you see what it keeps oscillating like that. Since sine of x does something like this, if you consider a horizontal line, it's going to fail the horizontal line test. So for one y value, you'll have multiple x values. So let's just start this over anew. So to resolve that situation, so that's supposed to be from pi to minus pi over 2, pi over 2. We just restrict the function sine of x to a portion of its domain. So we only consider the values between minus pi over 2 and pi over 2. So we start here, we move up, and we go to here. So we just consider this single arc in this sine function, just like that. And only on this domain do we say that the function sine of x is invertible. So the function arc sine, or sometimes it's denoted with sine minus 1, is the inverse function of sine, but sine restricted to the domain minus pi over 2 to pi over 2. Because on this restricted domain, the function sine of x is invertible, because on this restricted domain, if you just look at the red portion of the curve, you see that it does satisfy the horizontal line test. So, for example, if we want to say, well, what is the arc sine of 1? Well, the arc sine of 1 is going to be pi over 2. The arc sine of 1/2 is going to be pi over 6, and so forth. So the arc sine function is, the outputs are going to be between minus pi over 2 and plus pi over 2. So by itself as a graph, the arc sine function looks something like this. So that's arc sine. This is minus pi over 2 and plus pi over 2. And this is y is equal to arc sine of x. So we can say that arc sine goes from the minus 1 to 1, and it outputs something between minus pi over 2 and pi over 2. So this would be the domain, and this is the range. So the inputs come from minus 1 to 1, and the outputs are between minus pi over 2 and plus pi over 2. Something similar happens with cosine of x. So for cosine of x, it starts up here, comes and repeats like that, so that's 2 pi, this is pi over 2, and so forth. So for the cosine function, we go from 0 to pi. So we just take this section of the arc and ignore the rest. So then cosine comes down like this and repeats. So to compute the inverse of the cosine, we only consider this portion of the curve between 0 and pi. So the arc cosine, or cosine inverse, is the inverse function of cosine restricted to 0 to pi. So we can say that arc cosine goes from -1 to 1, and it outputs something between 0 and pi. So if you are at, for example, -1, arc cosine of -1 is going to go back and give you pi. So that's going to give you the value pi. And the arc cosine of +1 is just going to give you 0, so we have 0 down here. So cosine, or arc cosine, looks like this. So this is what y equals arc cosine of x represents. So another important note is that sometimes you'll see something like y is equal to sine squared of x. And this literally represents the output sine of x raised to the second power, or it's equal to sine of x times sine of x. Or you'll see sine cubed x, or sine to the 7th x, and so forth, and this just means take the output and raise it to the 7th power. There is one exception, and that is sine inverse of x. So this is not equal to 1 divided by sine of x. So in other words, it's not equal to sine of x raised to the -1 power. For this special function here, this special case, this refers to the inverse function. So it refers to the arc sine and not the -1 power. So finally, we have to, and that same thing holds for arc cosine and arc tangent. So sine to -1, cosine -1, and tangent -1. None of these mean sine of x to the -1st power. It means the inverse function. Okay, so those are 3 special exceptions to the rule. So now let's look at the arc tangent. So we saw earlier that the arc tangent goes from -pi/2 to pi/2, and then it repeats. So we're going to restrict this to the section of the domain between -pi/2 and pi/2, and it's actually undefined at those endpoints. So it's supposed to be something like that. So it's actually undefined at -pi/2 and +pi/2. So the arc tangent, so this is tangent of x. So the arc tangent is the inverse function of tan x restricted to the open interval -pi/2 to +pi/2. So arctan goes from -infinity to +infinity into -pi/2 +pi/2. That's because every single y value is actually hit upon by the function tangent of x. So if we want to graph arctan of x, we get something like this. So it's +pi/2, and then down here we have -pi/2. And this is what y equals arctan of x looks like, just like that. So those are the basic trig functions with no modifications.